lesson is 2.1, I can solve one-step equations. And whenever we're solving equations, the goal is to get the variable by itself. And we do this by undoing whatever is being done to the variable or using the inverse operation. So we're going to make a list of inverse operations to begin with. Inverse operations. And we're going to list out all of the inverses that we've used so far. So the opposite or the inverse of addition would be subtraction. The opposite of subtraction would then be addition because they undo each other. The opposite of multiplication or the inverse of multiplication is division. And the inverse of division should be multiplication. And you did all of these kinds of equations last year. The only one that's new for this year is the opposite of exponents. And the inverse of doing an exponent would be to do a root. So if something is squared, we would take the square root. If something is cubed, we would take the cube root. So we're going to use these inverse operations to get the variable by itself. So the first kinds of equations we're going to do are addition equations. So I'm going to do some addition equations. Example 1 will be x plus 2 equals 4. And so to get the variable by itself, actually, we're always going to start by drawing a line down the equal sign so that we remember whatever we do on this side of the equation, we have to do on the other side of the equal sign. And we want to get x by itself. We added a 2 to the x, so we have to use the inverse, and the opposite of adding is subtracting. So I'm going to subtract 2 from this side. Whatever I do to the left side, I have to also do to the right side. And then we'll kind of balance and see what's left over. So 2 minus 2 is 0, so this part goes away. I just have an x left over. And 4 minus 2 is 2. So we get x equals 2. And we can check our work by plugging 2 back in for x. So if I plug 2 back in for x, 2 plus 2 would equal 4. So the solution to this equation would be 4. We're going to do another addition equation. We're going to do 1/2 plus a equals 3/4. And same thing, we're going to start by drawing a line down the equal sign. We want to get the a by itself, so we're going to do the opposite of what's being done to the variable. The opposite of adding 1/2 would be subtracting 1/2. Then I'll balance each side. 1/2 minus 1/2 is 0, so I just have an a left on the left side. Then to do 3/4 minus 1/2, I might need to make a common denominator. So I multiply this one by 2 over 2, so I have 3/4 minus 2/4, which gives me 1/4. So a equals 1/4. If I plug 1/4 back in for a, 1/2 plus 1/4 is 3/4, so I know I did this one correctly. Let's just do one more addition equation. Let's do, for example, 3c plus -5 equals 9. So the opposite of adding a -5 would be to either subtract a -5 or we can add a +5. Our goal is to make this part into a 0. So to make this into a 0, we would want to add a +5 because -5 plus +5 are 0. If I add 5 here, I have to add 5 here. So I have c equals 14. And again, I can check my work by plugging it back in. 14 plus -5 would equal +9. So I know I did this one correctly. Let's do some subtraction equations next. So I believe we are on example 4. So here's some subtraction equations. Example 4 is going to be h minus 1/3 equals 2/5. So there's two ways you can think about subtraction equations. The first way is we could think the opposite of subtraction is addition. So the opposite of subtracting 1/3 would be adding 1/3. So I'm going to add 1/3 here and 1/3 here. And then this is really a -1/3 plus +1/3, which is 0. So I just have an h left on the left side. And then we have 2/5 plus 1/3. I have to make a common denominator, so I'm like these both into 15ths. So I have 2/15 plus 5/15, which is 7/15. And again, if I plug that back in for h over here, 7/15 minus 1/3 will give me 2/5. There's another way we can think about subtraction equations, and that's, so I'll do for example 5. If I have y minus 3 equals 4, for every other problem we've done so far this year, we said that the first step was to always change the sign in the one behind. So let's try that here. If I do that, I get a negative 3. The opposite of a negative 3 is a positive 3. Negative 3 plus positive 3 is 0, so I'm just left with a y on the left side, and then 4 plus 3 is 7. So my two ways are either thinking the opposite of subtraction is addition, or changing the sign of the one behind and then thinking the opposite of a negative is a positive. Either way, we end up adding to undo subtraction. Next, we're going to do some multiplication equations. So the first one will be, let's do example 6, negative 9x equals 18. We're going to start by drawing our line down the equal sign. Let me straighten this out a little bit. We divide by negative 9 to get x by itself. Sorry, I kind of skipped some steps. The opposite of multiplying by negative 9 would be dividing by negative 9. Negative 9 divided by negative 9 is 1, so I have just 1x left over, or just x. 18 divided by negative 9 is negative 2. For example 7, I'm going to do 0.3 times d equals 4. Sometimes I think we get a little bit worried when we see a decimal, but we should realize that we can use the same procedure. So the opposite of multiplying by 0.3 would be dividing by 0.3. Whatever I do to the left side, I have to do to the right side. 0.3 divided by 0.3 is 1, so I have 1d over here. 4 divided by 0.3 is 13.3 repeating, or 13 1/3. Okay, let's do some division equations next. So for a division equation, let's do, for example, 8x divided by 5 equals 7. The opposite of dividing by 5 is multiplying by 5, so I have to do that on both sides. And I don't write multiplication below. It makes more sense to write it to the left or on the right side. Then I can turn this into a fraction, and I can cross cancel. 5 goes in here one time and in here one time, so this just becomes 1x. And then 7 times 5 is 35. For my next division equation, I'm going to do w divided by 0.5 equals negative 4. The opposite of dividing by 0.5 would be multiplying by 0.5. Again, these would cross cancel and I get 1w. And then negative 4 times 0.5 would be negative 2. Okay, and then I'm almost out of space, but I need to do some exponent equations. And we've seen these before in chapter 1. So equation like x squared equals, this will be example 10, 64. The opposite of squaring would be taking the square root. The square root of x squared is x. And then the square root of 64 is 8. But if you remember from chapter 1, we have to do 8, positive 8, and negative 8, because if I do negative 8 times negative 8, I'll get a positive 64. And then for example 11, let's do y cubed equals negative 216. And then the opposite of cubing is taking the cube root. So I get the cube root of y cubed is y. The cube root of negative 216 is negative 6. For cube root problems, we only have one answer because a positive 6 times a positive 6 times a positive 6 will give me a positive 216, so that wouldn't work for this one.